Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, one of our friends requested for caching and broadcasting in Spark, so let's discuss on this today. Cache is used to persist RDDs and data frames in memory across multiple stages of Spark job. By caching the data, Spark avoids recomputation and it speeds up the process when an RDD or DF is cached. And that time, the cached data can be stored in memory or the disk depending on the available resources. And caching is useful when you have RDD or data frame that is used multiple times, like maybe while working with interactive algorithms or when you will have multiple actions need to be performed on the same data set. And caching can be done explicitly using this dot cache, this transformation, okay? And are also if we wanted to use for any desired storage level, we can use the persist as well. There are two detailed videos present on what is caching and what is persisting and how many levels of persisting that we can use. I mean memory levels, storage levels are available, using which we can what you can use in the persist function, right? So all these are available in the videos. I am giving it in the I button. Please check if you are mainly looking for the persist and options from that. Okay. And in this example, right, let's take some example. Here we are creating a data frame by reading a CSV file. And then we are doing the cache here. Means input data frame. Sorry, here it should have this input df dot cache. And once you cache that data frame, then what will happen? It will hold the data frame in memory, and whenever you are performing any action or transformation on that particular data frame, it will not recompute again, but it will take the data from that cached memory and it will perform the subsequent action. So here we are saving the time of that recomputation, which will give us the speed in the job, like the total completion time of the job will be reduced. This is why we use cache here. Okay. Next. And also we know, right, we have seen Spark is already has the capability of using the cache. And why do we need it, this kind of explicit caching, right? So as we know, Spark is actually capable of caching that RDD or DF automatically while doing the computations. So it is not always necessary to use the caching explicitly. Okay. And when talking about this lazy evaluation, right, the Spark employs a technique called lazy evaluation, where transformations are not executed immediately. Instead, Spark builds a lineage graph to track the transformation applied to the data. DAG, okay? When an action is called, Spark evaluates the entire lineage graph and computes the results. In this process, Spark automatically caches the immediate results that are reused in the multiple operations to avoid redundant computations. So, here then already Spark is doing it, right? Then why we need to explicitly use means when you are running some kind of iterative algorithms or some multiple times you need to recompute the data set based on a single data set, or some there are multiple wide transformations are used in the code like sorting or reduce by key or something. So many other transformations are used, and your job is taking so much time while performing for computing those wide transformations, or you have some limited memory and you wanted to ensure that only a particular data set should be cached. Only in these scenarios we can explicitly use this cache transformation, okay, calling this cache. But in normal scenario, there is no need to explicitly declare the cache and Spark automatically takes care of it. Why I am stressing this point is it might cause some shuffles or some delays in the job because of unnecessary extra caching of your data set. So use it wisely, use it when you are having any iterative algorithms and more of wide transformations, or you see that you have to persist some data and you have to persist in some scenarios. Use this cache function only in that scenario. Okay, now you see here, right? So this is how we see the cache and this will be done. Without this, using this function also, these simple transformations will be faster in Spark. Clear? Now let's go to the broadcasting. What is broadcasting? Broadcasting is a mechanism in Spark to efficiently distribute the read-only variables to all the worker nodes. So, these kind of things are particularly useful when you have some lookup table or some kind of a small table that needs to be joined or that needs to be do some data process with larger sets of data. Okay, for any transformations or actions need to send entire data set to the worker nodes. In for such kind of cases, we use this broadcasting. So what will happen in the broadcasting? Broadcasted data is stored in the executor's memory in a serialized format. So when you broadcast a variable, the data is serialized in the driver, and that driver program will send that serialized object to each executor. So what will happen because of that? The serial data is then deserialized and stored in the memory of each executor. Okay, so what kind of format it will be stored means it is depending on type of variable that is being broadcasted. Like Spark uses Java serialization or Cairo serialization, and by default Java serialization is set. Okay, but we can also change it to Spark Cairo serialization. There are some options we have, settings we have, we just need to set it up. Okay, so what will happen, why the serialization is, the serialized object is stored in a compressed format in executor's memory, which helps to reduce the memory footprint. It allows each executor to efficiently access the broadcasted data during the execution of tasks without requiring additional network communication. Okay, so now let's see this in the diagram. So if you see this diagram, right, we have first one is for the caching example. So here what are we doing is, in this example, driver programs create a data frame and it performs a caching operation. Let's say we have seen some code in the previous slide, right? We are creating a data frame and then we are caching it. In that case, what will happen? It creates the data frame and it performs a caching operation on that. When the data frame is cached, it stores the memory or on disk, or if we are mentioning any persist of any storage level, in that level it will store as per the Spark storage strategy. After the caching operation, the data frame is partitioned across all the executors in the cluster. Each executor stores its portion of data frame in its local memory, which is we always known as in-memory storage. So this will be stored in this in-memory storage. Okay. Then this in-memory storage on each executor contains the actual data of the cached data frame, and that is why it allows the quick access during the subsequent computations. Then how the driver program will come to know about the caching is with this pointer. The driver program maintains a pointer or reference to the cached data frame, which enables it to coordinate operations on the data frame across the executors. Okay, so during the any task execution, the executor can access the relevant partition of the cached data frame from its local in-memory itself. So thus it avoids the need of any network transfer or recomputation. So the distributed caching mechanism improves the performance of subsequent operations that requires the cached data frame. Clear here? So this is how the caching will happen in the memory. Now coming back to this broadcast variable. So what will happen here? The driver programs creates the broadcast variable in serialized form. In this, actually what it does is, even in the serialized form, first it divides the data whatever we are trying to broadcast into smaller chunks. Those smaller chunks are then sent to the block manager. Then here from this executor, it tries to access the object from the block manager, and then after accessing it, it deserializes it and it saves that copy into this local to the executor, so that it is readily available for the computations. So when you are executing some tasks on each executor, the task can access this local copy of the broadcast variable without needing to transfer it over the network repeatedly, because the same file is maybe joined. If you take, right, the same file is getting joined with the data which are available in many executor nodes or many worker nodes. We don't have to do that shuffling for accessing this data, because now we have this broadcasted data local copy in each executor. Okay, so this is how we have this how this driver creates the broadcast variable, it serializes it, and then it sends the serialized format through the block manager, and the executor can access that object, and then it deserializes it and stores in the in memory of this executor. So these are the two things that we need to know about the caching and broadcasting. So even though there are totally different concepts, I mean both are related to memory, but on a summary, cache is used for any speeding of the transformations or computations, and if you wanted to persist the data particularly to a storage level, then we explicitly use the caching. Otherwise, we will leave it to Spark. And when we use this broadcast variable, when you have a lookup table or something, like in the previous example, sorry, we did not even discuss about this example. So if you see here, right, here let's say we have a lookup table like that, country code is there, country names are there. So we may have seen lot of lookup tables, and instead of using the normal joins which will give us shuffle for accessing this lookup table, we copy that using the broadcast in each executor, so that it will be faster for performing any kind of transformations, and then we get very quick results. So there is a video on how this lookup table works and how to map the, so this is the map that we are using here, right? So how to map this particular what is a components, there is a very detailed video on that. I'll give it in the I button. Please go through that and let me know if you have any queries. So when you have a smaller data set and lookup kind of table, then you broadcast it. Otherwise, use normal joins. I mean, just see how we can consider these functions is, first analyze the data. What kind of the data we have, what kind of memory we available for us, like what is the cluster configuration, and what is the shared memory that is going to available for our job along with the other ongoing jobs. Based on all these, see the data and then decide whether you have to broadcast it or simple join is enough. Okay, so using of more functions will again lead to more of overhead on the program. You analyze the data and then decide which is useful to you. Okay, so then we see, right, this diagram we have already discussed. So this is about caching and broadcasting, friends. If you have more questions, please message in the same video under you have this comment section. Please message me there, and thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.